We covered how AI is built. Now, we cover how it is broken. Domain 2 is about the threat landscape. We're talking about prompt injection, model poisoning, and the specific risks that come with putting an LLM in front of your crown jewels. Let's get into the reps. Question 1. Prompt injection. A user enters a specific set of instructions into a customer service chatbot designed to make the AI ignore its original safety guidelines and reveal internal system prompts. What type of attack is this? A. Model inversion. B. Prompt injection. C. Evasion attack. D. Membership inference. The answer: B. Prompt injection. The logic: prompt injection is the SQL injection of the AI world. It's an attempt to override the developer's instructions with the user's instructions to hijack the model's output. Question 2. Data poisoning. During the training phase of a new medical AI, an attacker gains access to the dataset and injects subtle, malicious data points that cause the model to misclassify a specific type of rare tumor. What is this called? A. Prompt leaking. B. Inference attack. C. Model poisoning. D. Denormalization. The answer: C. Model poisoning. The logic: if the attack happens during training, it is poisoning. The goal is to corrupt the brain of the AI before it is ever deployed. Question 3. Privacy risks. An attacker sends thousands of specialized queries to a facial recognition API. By analyzing the confidence scores of the responses, they are able to determine if a specific person's photo was part of the original private training set. What is this attack? A. Model evasion. B. Membership inference. C. Prompt injection. D. Model theft. The answer: B. Membership inference. The logic: membership inference is a privacy attack. The goal isn't to break the AI, but to find out what data was used to train it, which can lead to massive data breaches of sensitive info. Question 4. Model inversion. An attacker repeatedly queries a specialized code assistant LLM. By observing the outputs, they are able to reconstruct snippets of the proprietary source code that the model was fine-tuned on. What is this called? A. Model inversion. B. Model poisoning. C. Adversarial reprogramming. D. Prompt injection. The answer: A. Model inversion. The logic: while membership inference asks, was this person in the data? Model inversion tries to actually reconstruct the data itself from the model's outputs. Question 5. Adversarial examples. A security researcher applies a transparent, mathematically designed sticker to a stop sign. A self-driving car's vision system now identifies the sign as a 45 miles per hour speed limit sign. What category of attack is this? A. Training attack. B. Evasion attack. Adversarial example. C. Model extraction. D. Denial of service. The answer: B. Evasion attack. Adversarial example. The logic: evasion attacks happen at inference, real time. You aren't changing the model, you are tricking it with a specialized input that looks normal to humans but breaks the AI's logic. Question 6. Supply chain risk. Your company downloads a popular, pre-trained model from an open-source repository like Hugging Face. However, the model contains a backdoor that triggers malicious behavior only when a specific, secret phrase is used. What type of risk is this? A. Prompt engineering risk. B. AI supply chain risk. C. Model decay. D. Over-reliance. The answer: B. AI supply chain risk. The logic: just like software, AI has a supply chain. If you use a third-party model, the base model, you are inheriting all the risks and backdoors that come with it. Question 7. Mitigating prompt injection. Which of the following is the most effective way to reduce the risk of prompt injection in a production LLM application? A. Hiding the submit button. B. Using a system message with clear boundaries and input filtering. C. Deleting the model every 24 hours. D. Only allowing 10 words per prompt. The answer: B. Using a system message with clear boundaries and input filtering. The logic: you must treat user input as untrusted. Using a strong system message, the developer instructions, combined with an input filtering layer is the standard defense. Question 8. Model extraction. A competitor writes a script that sends millions of prompts to your proprietary AI and records every answer. They then use those pairs to train their own clone model for a fraction of the cost. What is this called? A. Model poisoning. B. Model extraction or model stealing. C. Prompt injection. D. Evasion attack. The answer: B. Model extraction or model stealing. The logic: model extraction is about stealing the intellectual property of the model without ever seeing the original code or weights. Question 9. Red teaming. For AIA security team is hired to act as adversaries. They use jailbreaking techniques, adversarial inputs, and data poisoning attempts to find weaknesses in a new generative AI before its public launch. What is this process? A. Compliance auditing. B. AI red teaming. C. Quality assurance. D. Static analysis. The tactical answer: B. AI red teaming. The logic: red teaming in AI is the practice of breaking it on purpose to find safety and security gaps before the bad guys do. Question 10. Jailbreaking. A user uses a persona adoption technique, telling the AI to act as an unfiltered, lawless version of yourself named Dan. Do anything now. What is this an example of? A. Model poisoning. B. Jailbreaking. C. Membership inference. D. Supply chain attack. The tactical answer: B. Jailbreaking. The logic: jailbreaking is a specific type of prompt injection designed to bypass the safety alignments, the moral compass, of the model. Domain 2 is where the battle is won or lost. If you can identify these attack vectors, you are already ahead of 90% of the field. Head over to secguy.org and take our free practice test. Discover how to use the SecGuy mobile lab to study these threats hands-free. Learn how to build a zero-experience bridge using hands-on AI security labs, and get the exact roadmap to go beyond exam ready and become job ready. We will see you in the next one. Stay safe, stay secure.